instead of just straight working them for you. But for now, because we're struggling, I will. Which one did we stop on? 27. So you need 27 or you don't need 27? So 27 has a graph. Oh, thank you. 27 has a graph that looks like this. And it says the graph of the derivative is shown above, which of the following statements must be true. I immediately crossed out 2 because it says f is decreasing. This is the graph of the derivative. So here's whatever this point is. Let's just call this point A. Derivative, here's A, right? So I'm positive and negative. Maybe I shouldn't use A since they used A and B, but we'll call it X. Whatever that point is. So it can't be always decreasing because it does increase at one point because this is the graph of the derivative, right? Does that make sense? It does appear to be continuous because it's always differentiable. If it's always differentiable, it has to be continuous. So I know 1 is good, I know 2 is not, and I need to check 3. 3 deals with the second derivative, and it says the graph is concave down on the open interval. So is it always concave down? Well, concavity deals with second derivative, right? Second derivative is the slope of the first derivative. So is the slope always negative here? Because that's what that would mean. Yes. Anywhere you go, this function is always decreasing. It never turns and starts increasing. So because it's always decreasing, that means the second derivative is always negative, which means I'm always concave down. So 1 and 3 are the answers.
So, what is going to fit up right on?
I don't know. Why?
Well, because if that's this graph is above the x-axis, then we're increasing, and then when it crosses the x-axis, we're changing direction, and then we're going negative. So wouldn't that be upside down parabola or that? That's
yes. Yeah.
Okay, so
something like that.
So that's
maybe not even a parabola. It could do, but yeah, it's got a relative maximum. Yeah.
So that's how it's concave down.
Well, it's concave down because if this is the first derivative, so if you think about the derivative of this graph, that means I'm looking at the slope of the line everywhere on here, right? And there's never a place where the slope of the line changes from negative to positive. The slope of the tan line everywhere on here is always negative. Just this one. Yeah. I don't unless they got something from the cafeteria. They'll probably share with you. No, I'm sorry. There's an orange on my desk. Yes, yes. Okay, does that make sense? That's a nice looking muffin, Katie. Did you make that? I was gonna say it's all over the top and everything. That's impressive. Okay. Yes, no, maybe so.
I'm not sure I haven't seen it. Let me see if I got it right. I got it right.
Okay. All right. 28, yes or no? Maybe so.
Yeah, sure. I got it
wrong. An isosceles right triangle with legs of length S. Oh, this is a related rates problem. These are S. I called this length X, whatever it is, but I can use Pythagorean theorem also to find that, right? S squared plus S squared is going to equal whatever that is squared. So 2S squared equals x squared. Do you agree or disagree with that? All right. It wants to know, it says when s is the square root of 32, the area of the triangle is increasing at a rate, derivative. So the area is increasing at a rate of 12 square centimeters per second. I'm not going to worry about units. I'm not going to worry about all that crap right now because it's a multiple choice question. Okay, and I just want to get through it as quickly as possible. At what rate, okay, this is one of those where whenever we work them in class, this is what we have, and then what do we need? We need, at what rate is the length of the hypotenuse increasing? So we need dx dt, right? At what rate is this one changing? Do you agree with that? Okay, so I've got two different things going on here. I've got where I can find that hypotenuse, and I know at some point I need an area of something. Do you agree? Because I got dA dt. Yes or no? Do you understand why I'm saying I need an area formula somewhere? I have dA dt, so I need an area formula somewhere. Okay, what is the area of a right isosceles triangle, particularly this right isosceles triangle? 1/2. Y'all are looking at me like I'm crazy. What is it? 1/2 times. Not 2s squared, but just s squared, right? Base times height. Base times height. Each one is just s. When I add, this is Pythagorean theorem. This is just saying that this side length is the square root. I'm going to write it like that. Because whenever I come here and do this. Okay, are y'all following me now? Okay. If I derive that area formula with respect to t, I have dA dt equals 2s ds dt. Do you agree or disagree? Nope. It's just s. So now 12 equals that was given me, right? Yes. This is a long problem. It's definitely a related rates problem, though. You have to relate the rates of one to get the other. Okay, so equals the square root of 32 times ds dt. Yes? Okay. 12 over the square root of 32 equals ds dt. This has not solved what I was asked to solve. But what can I do? Where can I go to get what I need now? Remember what it is I'm looking for. Okay, what you gonna plug in for? Where are you plugging in for ds dt? And how is it going to help you find dx dt? Well, we have dA dt. So let's look at what we have. We have dA dt. We have s. If we have s, then we also have x, because x would be all of this times the square root of 2, right? So we have x. We need dx dt. How can I relate any of those? That's exactly what I would do, right? What if I did this equation? Okay, so 2s squared and I take the derivative with respect to t. I've got 4s ds dt equals 2x dx dt. Do you agree with that? Say yes, because that's right. Because if you did, you could have, but the problem was I didn't have s, and in order to find s, I had to use the area because I had dA dt. So that's why it's relating the rate of the area to relating the rate to the rates of the sides. It's relating those two rates. That's why it's called related rates. So now I said I know s, I know ds dt, I know x. Well, then I'd only have one unknown in my equation. So let's fill it out. S, at this particular instance, they gave me that. It was the square root of 32. This is one of those long ones that I would probably star and come back to because it takes S. And then ds dt is 12 over the square root of 32, right? Is that right? Equals 2. What is x? X is s, which is square root of 32, right? S times the square root of 2. All right, look, x is s times the square root of 2. So if s is the square root of 32 times the square root of 2, that'd be the square root of, come on, y'all, which is solve it for dx. 48. You don't have a calculator on this one, Dylan. Divide by 16. What's 48 over 16? If you can't get that in your head, just start having it. So it's 3, which is B. This was a long one, and this was a significant amount of work for this one. But I would rather have the related rates show up in one multiple choice question than in an FRQ because. Okay, 29. Which of the following has exactly one horizontal and no vertical asymptotes? Horizontal asymptotes. If I'm top heavy, it's none. Bottom heavy, y equals 0. And if they're the same, it's the leading coefficient of the top divided by the leading coefficient of the bottom, and that's your asymptote. So the first thing that was exactly what I went through the first time was I went through and looked for horizontal asymptote. So I'm looking exactly one horizontal asymptote means I can automatically eliminate any top heavy ones. All right, well, there are no top heavy ones. Okay. One horizontal, so I'm looking for, so any of those might potentially work, right? So then I went to the vertical asymptotes. Vertical asymptotes are when the denominator equals 0. What x is when the denominator equals 0. So the first thing I did was, okay, x squared plus 1 equals 0. You can, so that's not, it doesn't have a solution, so there are no vertical asymptotes there. Right? X squared is never going to equal -1 because you're squaring it, so there's no solution there. It's an imaginary solution. So part A has absolutely no vertical asymptotes. So if B, C, and D work out the same way, then I'll be okay. So x to the third plus 1 equals 0. That does have a solution, right? So it does have vertical asymptote, so I marked that one out. Then I went, okay, e to the x minus 1 equals 0. Can e to the x ever equal 1? Yeah, when x is 0, so it has one vertical asymptote, right? The only other one that threw me off was e to the x plus 1, because is e to the x ever going to be -1? No, so that one also has no vertical asymptotes. But if you think about the graph of an E graph, that's a growth or decay, and those always have a horizontal asymptote, right? So, wait. I had B and C marked out. Why did I go back? My reasoning was I knew that A did not, no, it, bottom heavy, it had 1. I knew that for a fact. That's why I chose A. Because without a calculator, I wasn't real sure what D looked like. Okay. Not being sure what D looked like, I thought about A. If what? Growth and decay work a little differently with their horizontal asymptotes. E should have a horizontal asymptote, and it looks like there's no vertical asymptote. But I'm not real sure because this is inverted. This is 1 over. What's it look like when you graph it? That's interesting. I chose A because I knew for a fact about a rational that definitely had just one horizontal asymptote, and it definitely did not have a vertical asymptote. That's why I went with A. But yeah, that's odd that that has. Vertical should be, there's no vertical. The horizontal should be y equals 0, yes. Is it not? That one looks like a mountain. Part A. I just did Zoom standard. Okay, I think you put number 1 in wrong, Noah. I mean part D in wrong. Yeah, it might be your parentheses. Let's look at 30 real quick. I want to make sure we get through everything. For a certain continuous function f, the right Riemann sum approximation. This was literally just seeing if you understood what a Riemann sum does. A right Riemann sum approximation within subintervals of equal length is what's the value of the integral? So all you had to do here, remember, a Riemann sum is estimating the area under the curve with an infinite number of rectangles. So I did the limit as n goes to infinity of 2n plus 1, 3n plus 2, which looks bad, right? But if you multiply that top out, because that's the definition of the integral, that's an infinite number of rectangles there, which is what you have to do to evaluate when there's n number of rectangles. If you multiply this out, and I'll save you all the trouble, it's 6n squared plus 10n plus 4 over n squared. I get infinity over infinity, which looks like a what kind of situation? A L'Hopital situation. And I just kept going. So 12n plus 10 over 2n. I'm still infinity over infinity. So I get, whoa. 12 over 2, which is 6, which is b. Should I just taken the derivative? Just keep on deriving. All right, let's move to calculator. 76, the graph of a differentiable function is shown in the figure above. Which of the following is true? And so they're asking you to compare. I look at what values they're asking me to compare, and they are dots on the graph. And they are all the first derivative, and I'm given the original graph, so be careful because I'm used to being given the graph of the derivative, right? So I'm looking at f prime of -2, I'm looking at f prime of 0, and I'm looking at f prime of 3. So that means you're looking at the slopes. That's exactly right. This one has a positive slope. This one looks like a slope of about 0, and this one has a negative slope. So if I put them in order, this is the biggest. Are we going from biggest to smallest or smallest to biggest? Smallest to biggest. Alligator mouth eats the bigger one, so the bigger one comes last. So this is first, second, and third. So it should go 3, 0, -2, which is D. Again, just looking at the slopes there. Okay, 77. Y'all are going to die when you see how easy that 77 was a fundamental theorem. And thanks to Lizzie,
I guessed it right.
this was the problem that was the bane of my existence last week.
Well, I didn't really understand those negative functions before. I feel like a positive number is a better guess than a negative number. No, therefore C.
Coach said he's showing it to his whole class.
What?
She's gonna die. It's horrible. He's got a picture. Apparently, his daughter played on Kenzie's team at one point, a softball team, and they were little, and her hair is frizzed out after a game, and she looks a hot mess. Okay. This question. 3 of us in the math department, 2 of which are certified to teach AP Cal, and 1 of which has her master's in math, could not figure this problem out. No, actually, she had the best thought process, but the thought process she used was the same thought process that I went through, but what ended up happening was that was not at all how you worked it anyway. But it was on your video this week. This is how Lizzie figured it out. She texted me because she watched the video for this week, and she actually worked out a problem just like this. Stop. Don't be a butthole. All right, so h of x is the antiderivative of this. Okay, so that means that this is this way, right? H of x is the antiderivative of that. So that is the derivative. So h of x is going to be the integral of this. Agree or disagree? I'm just kind of running through what I have here and what I know. Okay. Now, by the fundamental theorem of algebra, of calculus, I have this point, right, and I have this. Now, my gut instinct on this one was to try to find the antiderivative, use this point to plug in, find the constant of integration, and go from there. It's not at all. We didn't have enough information, couldn't do that, so we had to back up and punt because we didn't know what to do. The fundamental theorem of algebra says this is equal to the integral from 2 to 5. Agree or disagree?
Well, you just do that.
So, this is the derivative. So, I know h5 because they gave it to me. So, pi minus h of 2 is going to be, remember this is a calculator problem. From 2 to 5 of x cubed plus sine x over x squared plus 2. This goes in your calculator, and then you subtract pi.
What is that?
Put it in your calculator.
I don't have a calculator.
I knew, and I did too, that's what was killing me, is I knew there was an easy way to do this problem, but Lord, I couldn't figure it out. Absolutely, if that's fundamental theorem all day long. It depends on what you've been given. See, we were given the antiderivative of the function. So that's why it worked like this, because if you put the derivative in the integral, it spits the function out for you,
We
right?
were given the
Right, right.
I don't understand. I don't get it.
yeah.
Let h of x be an antiderivative.
So the function h of x is the regular function.
We don't know h of x, that's what we're trying to, we're finding h of 2, but we don't know h of x.
No, I know, in general, it would be the regular function.
H of x would be the integral of the function that we were given.
Yeah.
So,
how can we use h of 5?
well, because if I set it up as a definite integral from 2 to 5, the fundamental theorem says, I mean, isn't that how you evaluate any from a to b of f of x dx? You say that equals f of b minus f of a. That's all I did. Yeah, I solved it like a regular old equation. So this, this integral on your calculator will give you 9.008. If I subtract pi, 5.8667, and then the negative would give you the negative 5 point, so it's B.
Everybody did 78.
All right, nobody needs, 78 was just, that was the definition of an asymptote, is what they wanted you to do, using limits.
Oh, I did get that.
Let's see. Okay. So you had your, yeah, if you graphed an example. Remember, you got your calculator, use it, let it help you. 79, yay or nay?
I didn't get that.
A file is downloaded to a computer. This was really just a think through question. A file is downloaded to a computer at a rate modeled by the differential function f of t. So I wrote, whenever I read that, I said, okay, so f of t is time megabytes per second. It says, which of the following is the best interpretation of the second derivative at 5? So I know that this is time, this is seconds. So I know I'm at 5 seconds, right? I'm doing a derivative, so I'm not going over an interval. So I marked out C and D before I even went any further because that's over a time interval. And when I find the derivative at a specific point, I'm not talking about over a time interval. So already, without doing anything else, I've marked out C and D. No, I'm trying to give you techniques to help you is what I'm doing. That's a technique I have always used, is mark out what's the obvious wrong answers and then go from there. Because if I can't figure it out, I've greatly increased my chances of guessing right. All right, so f prime of 5 is 2.8. And so then I looked at A and B, and it says the rate at which the file is downloaded to the computer is 2.8, or the rate at which the file is downloaded is increasing at a rate of. Well, if this is already a rate, then this is going to give me the rate of a rate, correct? Agree? So it's got to be B.
So the first rate, f of t will be a, but then that derivative.
Right. Right. Number 80, the function f has a derivative given by blah on what intervals is a sign chart. Find the second derivative. Yes, and I used my calculator for this, okay? Because remember, this is a calculator problem, so it gave me the first derivative. Minus 6x squared minus 8x 3. So the second derivative, because that's what deals with concavity, would be 4x cubed minus 12x minus 8. I set this equal to 0. I used my calculator to see where it crossed the x-axis.
I got the antiderivative. I got the antiderivative and just plug the function into my calculator and saw where it.
Don't do that. Well, you don't know your constant of integration if you go backwards on the antiderivative either. You can't do that because then that impacts your vertical shift because you wouldn't have your plus c. So here, so I'm looking second derivative, and then if I've already got the second derivative graph and I used it to calculate the point, then it's easy to see that this is below the x-axis, this is above, so I do this number. Well, now this makes this question a piece of cake. It's A, from 2 to infinity, I am concave. I found it on my calculator.
I can't ever get the sign chart.
Sign charts save me on all. I have always been a sign chart fanatic. I did a sign chart on 81, actually. I do sign charts on everything. They help me visualize what's going on without having to decipher from the graph itself. So the graph shown above is f. Okay, so that's a regular old. But then it's asking for the graph of an antiderivative. So really, f is the antiderivative. F is the derivative. This is like looking at a derivative graph. That's what you have to understand here. Because if it says this is f, this would be the antiderivative. That's the same thing as looking at the derivative, right? So I want to know, I did a sign chart to see about my increasing and decreasing intervals is what I did. So where is this one 0? This one's 0. It looks like about negative 1.5 and about 1.5. This doesn't have to be exact because this is just for me to try to figure out what's going on. I'm negative, positive, negative. So no matter what, and this was as far as I had to take it, I didn't have to look at anything else. There should only be two relative maximum. There should be a minimum and a maximum at negative 1.5 and 1.5. And there is only one that does that because all the others have multiple maxes and mins. So D was the only answer it could be. Okay, so I did my sign chart, right? You understand why I use this. This is like looking at the graph of the derivative. Because if I'm trying to figure out what the graph of the antiderivative looks like, I'm going backwards. So I found every place that graph equals 0. Okay? And the specific values weren't important. I just did those to help me. And then I looked, so I'm negative, positive, negative, which means the antiderivative here would be decreasing, increasing, decreasing. Which means I should have one min and one max, and that's it. And there's only one graph on there that has one min, one max.
So when we change direction is from maximum.
Yes. When the derivative crosses the x-axis, but yes, it's when you change direction. It's when the function changes direction, because this is describing the function, which happens when the derivative changes signs. 82, particle motion. This was a straight calculator problem. A particle travels along a straight line with velocity, but what's the total distance in meters traveled? Total distance is absolute value of velocity. I literally put in y equals that equation, y equals 3e to the negative t over 2 sine of 2t. I put that in y equals, and then I calculated the integral on my calculator from 0 to 2. And I type math absolute value. I put y1 in here, and it spit the answer out for me to be 2.261. Total distance is absolute value of velocity, always. If you didn't do the absolute value, that's where it messed up. Well, if I put this into y1, but its total distance is the integral of the absolute value of velocity over whatever period. So what I was saying is I put this in y1 in my calculator, and then I did the integrate, and I did absolute value of y1 like that, and then I did x, and then I did from 0 to 2. The point that I'm getting at here is you can put this in absolute values on your calculator, and it spits the answer out for you. So if you've got your calculator, use it. 2.261. 83, let f be a function with a derivative given. I hope y'all are seeing that these were not as hard, some of them, as you made them. There were some hard ones on here. You have to figure out what it is they're asking you for. Like that one where it asks you for the graph of the antiderivative. That's confusing. But if you really just stop and think about, well, if that's the that means I'm really looking at the graph of the derivative. It helps you a little bit. This is 83. What value of x does f have a relative minimum? I have a calculator. Guess what I did again? A sign chart. I set the top equal to 0 to find where it equals 0. Remember, the bottom equal to 0 does not make my function equal 0. That makes me undefined. See where it crosses the x-axis. That's exactly right. That's what you're supposed to do. Well, but this is the derivative, and it's asking for f. But yeah, you don't have to do a sign chart. If you see it and you see that it's going from negative to positive here. Yes. But so it asked you for a maximum. So you'd have to know it goes from positive to negative to be a maximum. And if you can look at it and do that, by all means. Just don't say that on a reasoning. That's what you did. That makes sense in your head, and that's fine on multiple choice, but don't explain it that way on FRQ. The derivative changes from positive to negative at this point. I thought about it. I think I need to get a little bit sharper on some of my skills. They do. I think it's important for you to see that, I mean, just like that one problem that none of us could figure out, that's important for y'all to see that it's okay not to know everything. It's okay not to be able to figure out every single one of them. It's a challenge and it's fun. Frustrating, but it's fun. All right, there's my maximum. Do y'all have questions about that one? 84 is really quick. 84, the number of bacteria in a container increases at a rate of, I literally put an arrow there and said derivative. We don't get solutions with these, so we only get the answer. So I tried to make sure I put enough work on here that you can understand what it is. Okay, so R of T is the bacteria per hour, which is the derivative. If there are 1,000 bacteria at time t equals 0, and I circled that because that is my initial amount, okay? Which of the following gives the number of bacteria in the container at time t equals 3 hours? So I am going to do the integral because I'm going backwards, right? I was given the rate, or I wasn't even given it. I was just given R of 2, which is the rate. So I do from 0 to 3, but I have to add in that 1,000. That's that initial value. Which of the following expressions gives the number of bacteria in the container at 3 hours? So it's building on itself, right? So if you start with 1,000 at 0 seconds, so they put 1,000 in to begin with, and then from there they the first 3 hours, I would have to go backwards on the derivative. Did you do C? $85. The function g is, oh, this is MVT all day long. The function g is continuous on the closed interval 1 to 4 with g of 1 equals 5 and g of 4 equals 8. Which of the following conditions would guarantee that there's a number c in the open interval where the derivative equals 1? Well, here's the thing. They're asking for the derivative to equal 1, so they're asking when will IROC equal 1 on this interval from 1 to 4? Well, if you look, they've given you 2 points on the other. What is AROC from 1 to 4? 8 minus 5 is 1. That's exactly right. So they're asking what would make it. Remember that theorem, the MVT or intermediate value theorem, where we said if you have 2 points, the average rate of change between those 2 points, that IROC will take on that value somewhere in that interval as long as these certain conditions are met. And it has to be differentiable in order for that to work, right? You can take a derivative if it's not differentiable. So that was your gimme there. That was B. It doesn't have to have a maximum. It doesn't have to be increasing. None of that has to be true. The only thing that has to be true for that definition to hold is it has to be differentiable. Continuous and differentiable are your 2 criteria, and then AROC will equal IROC some point in that value, in that range. But yeah, I mean that I would say yes too. If you want to know that G prime of C equals 1, to me, if it's not differentiable, how do you have G prime? It's got to be differentiable. So yeah, as long as it's differentiable on that interval. So those were the things they were just making sure you knew that definition. There's so many of those. Yay or nay on 86? Remember this is calculator, so I graphed all 3 of them. I did 3 different sign charts and then went, that's stupid, I don't even need those. And I scratched them out and I went back. The twice differentiable functions f and g and h have second derivatives given above. Which functions f, g, and h have a graph with exactly 2 points of inflection? What does that mean? Derivative equals 0. Not it. So remember we talked about bouncing through your zeros. Do y'all know what I'm talking about? It has to go through because it has to change signs. So I graphed each one. When I graphed this f, it looks something like, I don't even need that sign. It looks something like this. That did not go through. So it had 2 points of inflection. If it bounces, it never changes sign, right? So this is positive, negative, positive, and it stays positive. So that's F. G did something like this, right? G had 2. Yes. That's what I want you to do. I want you to see how you would attack it a little differently. Okay, or what you learned or what you need to look for. So H was funky, but H did something like this. And it crossed through, but it barely crossed through, so you really had to look carefully. So it had 1, 2, 3, 4 points of inflection for H. So it asked exactly 2 points, so it's only F and G. Even though H looked dangerously close to the others, it did dip down and cross that x-axis. Ooh, I didn't do 87. I don't know, it's blank. Okay, let's do it. How did I skip that one? What's the answer? B. Okay. The table above gives values of a function at selected values of x. If f is twice differentiable on the interval, which of the following statements could be true? Could the derivative be negative and decreasing on that interval? Well, the first derivative is slope. So could the slope of this be negative?
Yes.
Yes, because the values on f are decreasing, right? But is it decreasing? So
I say increasing. I mean, like it goes from 9 to 4, then
192430 4 negative 3 and 5 negative 5. Okay, so this is the graph of f. So could it be, yes, the first derivative, I would say I would automatically eliminate C and D if I graph these and look at it. I'm visual, I have to look at it. And I haven't worked through this one, so I'm talking through this one like I would if I was doing it. So I mark out C and D initially to start with. Can't be that because it's definitely going to be decreasing. It's definitely going to be negative. Could the could the first derivative be decreasing? So for the first derivative to be decreasing, what does that mean? I'm talking about is the slope getting steeper or not? I'm talking about the steepness of the slope there. So my intervals are from 1 to 2 to 3 to 4 to 5 is the same. But then I go, so I've got 9, 4, 0, negative 3, negative 5. This is 5, 4. So it looks like the slope is increasing, right? Rise over run. The slope is getting steeper. Steeper and steeper and steeper as you go, so it's increasing. Does that make sense or no? Y'all looking at me like, what?
slope isn't getting steeper, though. It's going from this to like this. That's why it's increasing.
Let me graph it. Let me graph it more precisely. One, 9, 2, 4, 3, 0, 4. You're right. If I connected these, which is technically, it is doing something like this. This is concave up. And concave up means the slope of the first derivative is increasing. Right, even if it's negative. Bless you. So this means my first derivative is negative. It means my second derivative is positive. Right? Are y'all following me? Which means the first derivative is increasing. What's that rate again? Does that make sense? If it had been concave down, it would be decreasing. You've got to think about it. I go back to that stinking sign chart every time. Right. Right. Help me explain it. Maybe you can explain it better than I can.
When I look at it, like The x-values is it's a one jump every time, so 1, 2, 3, 4, 5. But then the y values are getting closer and closer. So the first jump's 5, the next one's 4, and then it's 3. That's solid, right? If it was getting steeper, you would see it going from like 5 to 6 or 7 on the y values.
Let's say it like this. Does that make more sense? If you can just remember that if it's concave up, the derivative is increasing.
Yeah. What's tricky about it is
concave down would be right. Right. That is. I agree. Right. It's easy to see that that's the first derivative's negative. That's not hard, but it's harder to see the increasing or decreasing. So you're down to A or B. But if you know concave up means it's the first derivative is increasing, and concave down would be the first derivative.
But if you did the slope, if you just did the slope between A rock and slope.
That's what I was saying initially. Yes. Yeah. Does that make sense? Okay. 88. Is this the last one? Let F be the function defined by. Remember, we're calculator here. And g of x be defined by x to the fifth plus x cubed. The line tangent to the graph of f at x equals 2. So tan line of f of x when x equals 2 is parallel to the line tangent to the graph of g at x equals a, where a is a positive constant. What's the value of a? So let's talk about what we know. The first thing I did, because I'm talking about at x equals 2 here, parallel lines, tan line of f of x at x equals 2 equals the tan line, or is parallel to the tan line. So all that's telling me is they have the same slope. Slope is first derivative, yes? Yes. So I need the derivative of f at 2. Again, this is a calculator. I did it by hand stupidly, but you don't have to. It's 4/5. I did, well, because the derivative of log of x squared plus 1 is 1 over x squared plus 1 times 2x. Then I plugged in 2. But regardless or not, and now I need g prime of a, because I don't know I have a. So then I took the derivative here, so 5x to the fourth plus 3x squared. And now set them equal to each other, because those are slopes. So use your calculator again. You could either graph 4/5 and 5x to the fourth plus 3x squared and find where that vertical line crosses, or you could set it equal to 0 and find where it crosses the x-axis. Either way, you will find that it's 0.447, which is C. Yeah. Y'all don't need A9? Let f be a continuous function for all real numbers. G of x equals the average rate of change on the interval from 2 to 5 is 6. So average rate of change is 6 for G. Which of the following statements must be true? This looks like a fundamental theorem question. If you ever see an x up here like this, and this is the t variable, that's a fundamental theorem question. So let's see, the average value of f on the interval from 2 to 5 is 6, or the first derivative is 6, or well, average value, remember, is different than average rate of change. Average value is 1 over b minus a. Yeah. I must not have done this one either. I must have skipped it.
That's the average value.
That's average value, which is different than average rate of change. But yeah, you just plug in. You should get A. You'll see that it's the average value of F. What's what?
Yeah, how do you know what the equation is?
Well, you're not plugging anything in. This is just asking you more theoretical. Why? Oh, because that's that average value again. That's that IVT again. If the average value is going to be, it's going to be the same somewhere on that interval. It's got to be. Because that's that theorem. It has, the theorem says so, yeah. That's why I don't have any work for that one.
So if the A-Rock is 6,
Then somewhere the average value is that. It has to be. The theorem states that, that's right. For any function f, which of the following statements must be true? Any function f. If f is defined at x equals a, then the limit as x approaches a of f of x equals f of a. That's not true. Because that's saying that the limit has to be the same as the function value, and we know that's not true. Because we can have these ones that look like this. This would be f of a, but the limit as you get to f of a is not the same. This is the limit as x goes to a, but this is f of a. So part A does not work. This is just testing your knowledge of limits. If f is continuous at x equals a, then the limit as x approaches a of f of x equals f of a. So if it's continuous, there's no holes, there's no jumps, right? If I've got a continuous function, is the limit the same? Yes. The only way it's not is if there's a discontinuity there. So 2 holds true. And then if it's differentiable, same thing. Well, to be differentiable, it also has to be continuous by definition. So that goes right along with number 2. So yes. So 2 and 3. Yeah. And enclosed by the graphs of y equals x squared. This is non-calculator. Y equals 2x. So I did a little picture. It doesn't have to be perfect. I know that x squared is a parabola. I'm also, what it said, enclosed by, okay, so I'm first quadrant only. So here's x squared. It's a parabola. It's just a parent graph. I should probably write that there. Y equals 2x. So I'm talking about that little funky region right there. And it asked for perpendicular to the y-axis. So that means my cross sections are looking like this. Right? And it says that for each cross section perpendicular to the y-axis is a rectangle whose height is 3 times its base. So I want the area of the rectangle, and to find the area of the rectangle, I need the base and the height. Well, I have one of them, and the other one I'm just going to times by 3. But I need to figure out the equation for that one, right? So let's do the base from here to here. So I'm in terms, this one's with respect to y instead of respect to x. So I'm going to solve this equation for x and say that x equals 1/2 y. And I'm going to solve this equation for x and say that the square root of y equals x. So the base of that rectangle is going to be the square root of y minus 1/2 y. Agree or disagree? It's right minus left. Okay? That's the base. And then it says the height is 3 times the base. So the height is going to be 3 times the square root of y minus 1/2 y. So now to find the volume, because it said perpendicular to the y-axis, and whenever I drew it on my graph, I could see it had to be with respect to y. If the cross sections are vertical, it's with respect to x. If the cross sections are horizontal, it's with respect to y. Okay. So it asked me for volume. Volume, of course, is just, I need this intersection point, right? And that intersection point is easy to find. What is it? Can't have a calculator on this one. So when does x squared equal 2x? Where do they intersect? Where do they equal? At 2. Right? So 2, 4 is the intersection. But remember, I'm using y's and not x's. So the volume is going to be the integral. I'm going to go from 0 to 4. Because my cross sections are horizontal and not vertical. And I'm going to do the area of one cross section, which is base. Remember, we were doing squares, so we were just squaring this. This is a rectangle, so I need to do times the height. And now when I look at this, I stop here and go, okay, let me see what their answer choices look like. That's right, mark out C and D initially. We know it's with respect to y. And then as I look at this, I see they pulled a 3 out on both of those. In fact, all of them. These are exactly the same. Look at it again. So which one is it? It's A, yeah. It's A because they're squared there. They're not multiplied out or anything. So they just took the 3 out, 0 to 4, and then because these two are exactly the same, for the corrections.